So one more question. The question is f of t is given. We need to find f of s, which is the Laplace transform of f of t. So this is the notation L curly bracket f of t, which is read as Laplace transform of f of t is equals to f of s. So whatever the function is given, what is the definition of Laplace transform? So it is a integral of f of t into e power minus st. So whatever function we are trying to find the Laplace transform of, multiply that to e power minus st, integrate from 0 to infinity with respect to t. So but we don't actually need to integrate anything here. So if you had to do this in this way, so in place of f of t substitute sine square e power minus st dt, we don't need to do that actually, because we know directly the Laplace transform of sine at, okay, which is a over s square plus a square, okay. And if we can use this already listed or already known Laplace transform of basic functions, that would be easy, right? But the given function is not directly in terms of sine. It is sine square, and it instead of having just at here, it has at minus something, some at plus something. Okay. So first we need to use our basic trigonometric rules and algebraic rules to convert this in terms of basic functions and then apply the Laplace transform. So how do you do that? Here we have two variations from the basic sign. So we have sine of something plus something, and we have sine square. Okay. So and Laplace transform, you cannot take Laplace transform of sine and then take the square of the Laplace transform. That is not how it works. Okay. So Laplace transform is only linear. Okay. So how do you do that? We have one formula. First of all, we have one formula, that is sine a minus b, or sine a plus b. Formula is sine a cos b minus cos a sine b. Okay, if we use this formula here, and where a is 2t and b is 1, and then take the whole square, okay, because we have square in the formula, okay, so that would be difficult, because that would be one way to solve this, okay. But product minus product square is a little bit lengthier. So instead what we will do is, first we will evaluate square. How do we do that? We know one more formula. Sine square theta is 1 minus cos 2 theta by 2. Okay, so this is one of the god formulas of the trigonometry, because this is used everywhere in engineering. So if whenever you have sine square and cos square, you should be able to convert them into power 1 terms. So if you have cos square, it is 1 plus cos 2 theta by 2. If you have sine square, it is 1 minus cos 2 theta by 2. Okay, so first we will evaluate the square. Okay, let 2t minus 1 as it is, and then we will evaluate the 2t minus 1. So if in place of theta we have 2t minus 1, right? So using this formula, trigonometric formula, what will happen to f of t? F of t is now 1 minus cos 2. In place of theta we have 2t minus 1. In place of theta we have 2t minus 1, right? So 2t minus 1 whole divided by 2. Okay. So this can be written as 1 by 2 minus cos 2 into 2t is 4t minus 2 into 1 is 2. 4t minus 2 by 2. Okay. Now simply it is Laplace transform of any number. Laplace transform of any number k is k over s. So this Laplace transform I can find. Here we have a cos term, and we know Laplace transform of cos at is s over s square plus a square. But it is not just at here, it is at minus something. So again we have to use a trigonometric formula to convert this to just cos. How do we do that? As sin a minus b, there is a formula for sin a minus b, there is a formula. So there is a formula for cos a minus b also. With the formula is cos a minus b is cos a cos b plus sin a sin b. So these are the trigonometric formulas that are prerequisite, that are required by you to know. Okay. So here if you are negative, you have positive sign here. That is not a mistake here. That is intentional. So using this formula, I'll get f of t as this 1 by 2 as it is, minus this 1 by 2 I'll take outside, and I'll write in place of a we have 4t, in place of b we have 2. Okay, that is cos 4t into cos 2 plus sin 4t into sin 2. Okay. in the previous questions, we have noticed that whenever you have cos into cos, we used cos A into cos B formula, but we don't need to do that here because this cos term and this sine term does not have t. So they can be simply considered as constant. The value of cos 2 could be something, I don't know, sine 2 is almost near to 0, that is 0 point something, and cos 2 will be 1 minus 0 point something like that, okay. But the point is we can consider them as a constant, okay, and we can keep them outside along with 1 over 2 while taking the Laplace transform, okay. So if you take the Laplace transform of this function now, f of s is nothing but 1 over Laplace transform of 1 over 2, okay, for this, minus this 1 over 2 is just kept outside. This 1 over 2 is different than this 1 over 2. This is a constant multiplier to the t function. This itself is a term, okay. So that's why we're taking Laplace transform of 1 over 2, and here we are keeping 1 over 2 outside. And again, cos 2 also I'll keep outside and take only Laplace transform of cos 4t, okay. I hope you understood why I kept cos 2 outside, because it's a constant. Then again, plus I will keep sine 2 outside and take Laplace transform of sine 4t. Okay. So at this point, we have simplified the given function square and a plus b in terms of just constant term, cos term and sine term. And we know Laplace transform of each of them. Okay. So using that, we'll get f of s as any number k, k over s, 1 over 2, 1 over 2s. So that is 1 over 2 over s minus 1 over 2, big bracket, cos 2 as it is. Okay, Laplace of cos 4t is, cos 8 is s over s square plus a square. In place of a, I have 4, that is s over s square plus 4 square. Plus sine 2 as it is, sine 4t. Sine 8 is a over s square plus a square. In place of a, I have 4, that is 4 over s square plus 4 square. Okay, so finally, simplifying further, we'll get 1 over 2s, 2 in the denominator, and this s will be multiplied, minus 1 over 2, minus 1 over 2. Both the denominator are s square plus 4 square, s square plus 4 square, so I'll just keep it as s square plus 4 square. And here in the numerator I have cos 2 into s, or I'll write as s cos 2, because if I write cos 2s, we will confuse it as cos 2s. It is not cos 2 into s, it is cos 2 into s. Okay. Plus 4 into sine 2, 4 into sine 2 by s square plus 4 square. So this is the Laplace transform of sine square 2t minus 1. We don't have to integrate, we have to use the basic formulas of Laplace transform from the list or from the table and just apply it here. This is the easiest part, Laplace transform part. But converting or simplifying the given function in terms of simple basic functions. Okay. So we have two variations here. One, we have, instead of at, we have at minus 1. Okay. And instead of power 1, we have power 2. We could have first simplified a minus b and then simplified square. But that would lead to complications. So I simplified square first and then simplified a 2t minus 1. So this is one of the formulas I used, and this is one of the formulas I used. Basic trigonometric formulas. At this point, it's very simple. And cos 2 and sine 2, if the term has no t in it, doesn't matter if it is exponential or cos or anything. If it doesn't have t, it is considered as constant. You have to keep it outside while taking the Laplace transform. Okay. So let's see another question.